Check this out. We've got something really fun today. This is so amazing. Oh man, again? 2.3b, Sine law and the ambiguous case. For our first example, we've got triangle ABC, and we're just given these three bits of information: angle A, and side B. So I drew a potential triangle here, and we want to determine the measures of all the other sides and angles. Let's start off finding angle B. So we'll use the sine law. Sine B over its opposite side is 42 equals, here's our couple here that we can compare to, sine 30 degrees over 24. Now we can just do some algebra, multiply both sides by 42, and we get that sine B is equal to 7/8. We take the sine inverse of both sides, and we get that angle B is equal to 61 degrees. Next we can find angle C. So C is equal to 180 degrees minus the other two angles that we already know, and that will give us 89 degrees. And last thing to find is little side C. So we'll use the sine law again, match it up with its angle, sine 89, and let's use the couple that we were given in the question. It's probably not rounded, it's our most accurate. So we got 24 as the side length, because this time side lengths are on the numerator, and in the denominator it's matching angle, or its opposite angle. Do some algebra, and we get that C is equal to 48 centimeters. Now there was an interesting thing that happened. We made up this triangle, and right here we had that sine beta is equal to 7/8, and we took the quadrant 1 answer. But we know that sine's ratio is also positive in quadrant 2. And why can't it be in quadrant 2? Well, it can be, and so we've got to solve this triangle again, but this time it's going to be an obtuse triangle, because this angle B is going to be greater than 90 degrees. So right here, we will take this angle here and use it as our reference angle for finding our quadrant 2 angle. So it'd be 180 degrees minus our reference angle, and that would give us 119 degrees as our solution in quadrant 2. So B could have been 119 degrees. Now let's find C again. So angle C would be 180 degrees, but this time minus 30 and minus 119 degrees. So it would be 31 degrees. And let's find side C. So side C would be here, and we'll use the matching or opposite angle there we just figured out and compare it to our couple that was given in the question. And when we do our algebra, we find that side C is 24.7 centimeters. Now, this question is very confusing because based on the information given, we don't know whether it was case 1 or case 2. So how can you tell? This is what's known as an ambiguous case. There's ambiguity left in this question, so we'd have to solve for both potential cases if this happens. So the big question is, when are we going to have to worry about this ambiguous case? So if they give us an angle and then a side length and then an angle, we don't have to worry. So if they give us an angle and then we know how long this side is, and they give us another angle, this is not a problem because these two side lengths will either extend far enough to make a vertex, and then we have a triangle, or they won't and we don't have a triangle at all. But they won't be two different triangles that it can make. If we're given side-side angle, so we're given a side length, we're given another side length, and then we're given an angle. We don't know how these two side lengths are orientated, and so we don't know what this triangle looks like. So there's going to be three different things that could happen if we're given A, and this is an angle because I capitalized it, and then side B and side A. So the first option is that no triangle exists if angle A is acute and A is too small here. It's less than H. And so if it's less than H, then it sort of just dangles here in the air and it can't make a triangle. Okay? And we don't usually have H given. So look at our sine here, our sine ratio. Sine A is opposite over hypotenuse. And we just rearrange that, solve for H here. And we get that H is equal to B times sine A. So instead of writing this, A is less than H, which we probably don't have H, we'll write A is less than B sine A. It means the same thing. So if we have an acute angle here and this happens, then there's no triangle. Same with this. If angle A is obtuse and A is less than B or equal to B, then we're not going to be able to create a triangle either. Option number 2 is that one triangle will exist if you're given angle A, side B, and side A. The first one is if this angle A is acute and A equals H, then we're actually having a right triangle here, and there's no other option. This is unknown, but still we can't really swing this side anyway to make a different triangle. This is the only triangle it will make. Okay, if angle A is obtuse like this and A is greater than B, then same deal. There's only one triangle it can make. It's going to go over here until it hits this line, which angle A said must be heading in this direction. So only one possible triangle here as well. And the last option for this is angle A is acute again, but A is greater than or equal to B. If it's equal to B, we created an isosceles triangle. If it's greater than, it's just going to come over here until it hits this line again, and that's only one possible triangle. The third option is when we have two distinct triangles, or we have the ambiguous case. And this happens when angle A is acute and when A is greater than the height, but less than side B. And again, we probably don't have the height, so we'll say greater than B sine A or less than B. Now you might be thinking that this is too much to remember. There's so many different cases here, and this is going to be very difficult. But let's take a look. Angle A is acute. If angle B is obtuse, you don't need to worry about the ambiguous case because it's taking up too many of the degrees, and you can't have ambiguity. So angle A is acute, that cuts out a lot of the cases right there. And then if you can just remember this rule right here with this, that should be enough. So A is greater than H and less than B, and if this is happening, then we're in the ambiguous case. This doesn't happen in any of the other cases. So just remember this and you should be good. In example 2, we're given angle A and side B. The first thing to note is that angle A is acute. Also to note is we're given side angle, and if you look in the sketch I made here, that wouldn't be included with the question because if we had this diagram, we would know what this looks like. So there wouldn't be any ambiguity. If we look at this, we're given side angle, looking counterclockwise here. So this could be ambiguous. Now I drew this to scale, and you can actually see that this 14 is much too long. Although we don't know this angle, so this side length here is free to swing around. Its only possible position is here. But let's look how our rule would work for this question. We want to check if the height, or B sine A is less than A, and that is less than B. So B sine A is 6.3, A is 14, and B is 10. So this isn't true. So therefore, no ambiguity. So solve this like normal. So let's find, if this is angle A, this would be angle B and angle C inside C. So let's find angle B, and that's matched up with 10. We'll compare it to sine 39 degrees over 14. Do some algebra here. We get that B is equal to 27 degrees. And then to find angle C here, we just need to take 180 degrees, subtract 27 and 39, and we get that angle C is 114 degrees. And the last thing we need to find is side C, so we'll use side C, match it up with its newly found angle here, and compare it to our couple, 14 over sine 39. Multiply both sides by sine 114 degrees, and we get that C is equal to 20 centimeters. In example 3, we're given that angle A is acute again. We're given side-side angle. We need to check this out to see if this is ambiguous information. Here's our key. B sine A needs to be less than A, and A needs to be less than B. So B sine A is 10, A is 14, and side B is 16. So that means that this question is ambiguous. In other words, the information here can represent two different triangles. We need to solve for both cases. So case 1 will be when we have an acute angle we solve for first. And we're going to do angle B here, so this one will be acute. So let's solve for that angle first. Sine B over its opposite side here is equal to sine 39 degrees over its opposite side here. Multiply both sides by 16, and we get that angle B is equal to 46 degrees. And that's acute. That's in quadrant 1. And that's probably the first one your calculator will give you when you do sine inverse of all of this information. Now, we need to find angle C, so that would just be 180 degrees minus 46 minus 39, and that gives us 95 degrees. And last, we need to find side C here, and we will use the sine law to find that. So C over sine 95 is equal to, and this time our side lengths are in the numerator, 14 over sine 39. Multiply both sides by sine 95, and we get that side C is 22 centimeters. Now let's go find this other triangle that this information could represent. And it comes from right here. We know that this was our quadrant 1 answer, and so it was 46 degrees. So we want our answer in quadrant 2, because we want this angle B to be obtuse in this case. So angle B here would be 180 degrees minus our reference angle, and that gives us 134 degrees. Now we do the rest of the question, except angle B is 134 degrees in this case instead of 46. So we'll find angle C, and it's 180 degrees minus 134 degrees minus 39 degrees, and that only leaves us 7 degrees for angle C. And then we just need to find side C. So we set up the same sine law here, except we use the angles from case 2 instead. And when we multiply both sides by sine 7 degrees here, we get that side C is 2.7 centimeters. It's a lot smaller because in this triangle, it actually looks something like this. So side C is very small compared with the larger side C in case 1. This was part of Trigonometry 3, solving problems using the sine law, including the ambiguous case. Here's some questions from the textbook. Give them a try, see if you know what you are doing.